Thank you very much, Eleanor, and good afternoon, everyone. And it's really great to be here. It's a real pleasure to have the conversation with Will. As Eleanor mentioned, I work on the applications of AI for climate change to improve climate impacts by businesses and organizations. Before we start talking to Will, I'll just give a quick introduction about who he is. Will Marsher is the co-founder and CEO of Planet. Planet is a satellite imaging company that operates over 130 Earth imaging satellites. It really has been a huge disruptor in the field of Earth observation in the last few years. And prior to that, Will was a scientist at NASA, where he worked on 2 lunar missions. His PhD is in physics, is from Oxford University, so a strong connection to the UK. Well, it's great to meet you.
Thanks very much, Sherif. Looking forward to this chat and discussion. Should I start with some slides, or how would you like to begin?
Yes, please do. So you're going to start with a few things about Planet.
Okay, to start with, just give you a brief overview. Let's bring up the slides if we can onto the deck. I'll just tell you guys a little bit about Planet. When we left NASA, we set ourselves this goal of imaging the whole Earth every single day and make the change that we see day to day visible, accessible, actionable. And it took us about 6 years to launch what became now the largest Earth imaging fleet of satellites. And we're still embarking on this mission to make it more democratized, and I'll tell you a little bit about that. Next slide. This we spent a lot of time first miniaturizing our satellites. So traditionally, satellites were about the size of a double-decker bus, and we took the latest technology of miniaturized electronics and sensor systems to miniaturize the satellites. So we made them just a few kilograms in the size of a bread box, and that enables us to launch many more and have much higher capabilities per unit mass. And mass is very expensive to get to orbit, and so that enabled us to launch a lot more Earth imaging satellites. Next slide. So this is a current fleet. We just have over 120 doves in orbit and 15 SkySats. So the doves literally image every point on the landmass of the Earth once per day at about 3.7 meter resolution. So the pixel is 3.7 meters. And we have 15 SkySats that have about 50 centimeter resolution. And so, but it can zoom in on specific targets of interest around the world at higher resolution, especially urban areas. Next slide. This is a video actually normally of how the system works, but essentially the doves act like a line scanner. They're all in one polar orbit, and each one takes a strip of images as it goes from north to south. But the Earth is rotating underneath, so that by the time the next one comes down, the Earth is rotated just enough so that it strips a set of images next to the prior one and ends up line scanning the planet. It's the first such system erected. Next slide. This is just some of the numbers. We, of course, have produced a lot of data. And now, for every point on the Earth's landmass, we have about over 1,000 images. So we have a deep stack of information about how the Earth is changing. We get down many terabytes of data every day from ground stations we've put around the Earth's surface. We've had 24 rockets take off the planet, putting up our satellites, over 300 satellites deployed. And we've actually got a whole bunch of launches coming up, and I'll mention a few of those in a second. Next slide. The fundamental premise is not being able to fix something unless you can see it. Earth imaging has been extremely helpful for helping us to understand climate and other phenomena around the planet. But when you image the Earth every month or two or every year, which is traditional, as you can see typically on Google Maps or other map systems, if you put the satellite layer, it'll be several years old. That's really great for helping us understand, but to actually get inside the human decision-making loop, to stop action, say to stop illegal fishing or to stop illegal deforestation or to actually change the behavior of humans, you need to get the information on the time scale of that change. And so, in deforestation terms, for example, you don't want to just wake up at the end of the year and there's a big hole in the Amazon. You want to see when there's an illegal logging road before they've taken down a single tree, and then inform the police to stop that. That's an example of things we actually do in countries, including Brazil. Next slide. This, just to give a contemporary example, this is the bridge over in Wuhan as the coronavirus hit. It's on a normal day. In the next slide, you'll see that the bridge is just completely emptied out. And so when the coronavirus hit, many people were saying, just what does it look like? What's going on around the world? And one of our things we really care about is helping to shed light. And so it started there, and then we looked further afield, next slide, and saw various things, planes stacking up at airports, next slide. And just we follow contemporary events, and this was a picture of the Black Lives Matter paint on the road just up to the White House there, just a few hours after they painted that image on the road there. I think it's super important to give visibility to those sort of movements. Next slide. I also, and perhaps we'll talk more about this, but we've assessed that we can help 13 of the Sustainable Development Goals. So the UN actually came out with a report last year that stated that of the environment-related Sustainable Development Goals, the vast majority, like about 70%, they don't know what's the status. So there's a small fraction that are going well, there's a small fraction that are not going well, and then the vast majority, they just don't even know how they're going. So the problem is there's a big data gap. If we are going to solve the Sustainable Development Goals, we need to be able to have the data to help people to inform their decision making. And we've assessed that we can help about 13 of the 17 sustainable goals, like monitoring all the reservoirs around the world to help with clean water, monitoring, of course, all the coral reefs to help with life below the water, and various other things. And I could talk through each one, but in the interest of time, next slide. And this is just an example of monitoring deforestation and disaster response. And this is after a mudslide. If you go to the next slide, you'll see the dramatic impact of the mudslide here. And it caused, unfortunately, a number of deaths there. And next slide. And this is a canonical example of deforestation along a river track in the Amazon. Next slide. This is just some tracking of refugees. Next slide. And this is some work we did on not just imaging all the coral reefs, but actually doing a classification of each different type of coral. It was the first time it's ever done on a global basis. And then now we revisit them every day to see if there's signs of ocean bleaching or signs of illegal fishing and things like that to help protect those coral reefs. Next slide. I just wanted to give a tiny insight into what's coming next, which is we're turning all of this imagery into information about the objects that are in it. This is a picture of the roads in red and buildings in blue in San Francisco. And we've done global runs of this, so we can find all the roads. In San Francisco, the roads are pretty well known, but in a lot of African countries, a lot of the developing world, we find that the maps are completely out of date, and we find all the new roads, find all the new buildings, help entities like the World Bank determine where they're being buildings are being put in flood risk zones or things like this. And so basically, we are building up an index of what is on the Earth. Just like Google indexed what's on the internet and made it searchable, we are indexing what's on the Earth and making it searchable, saying there's a road, there's a building, there's a plane, there's a train, this is a ship, and what have you. We can then just turn the Earth into a database of what's on the Earth over time, and then that can help us to understand changes and query the planet. So I call that vision sort of queryable Earth. with that, that's it. I think that's the final slide. Can you go to the next slide just to check? Yeah. So thanks very much, everyone. That's a quick overview. Sherif, back to you.
Thanks a lot, Will. It's I mean, really fantastic to see how things have changed since from 10 years ago, for example, and a lot of the changes have been brought in by Planet and the way you've approached the industry. And I know you've got you had some big news today as well that I've seen. Do you want to say something about that?
Yeah, sure. It's a curious timing, but and this is why I'm wearing my SpaceX T-shirt here. Today we're announcing a few different exciting developments in our the 15th higher resolution satellites. We've spent the last 6 months doing some really good and cool improvements to those systems that we're announcing today. A set of new capabilities. The first is that we lowered all the satellites so that they could improve the resolution from about 70 centimeters to about 50 centimeter. That enables things like Google really wanted to understand road markings, and this at 50 centimeters you can just about tell them, and lane structure. It's really good for mapping. And then a second thing is that we announced a sort of a tasking dashboard, which enables anyone who's a client of ours to task the satellites automatically. They just put in a lat long, the image automatically comes back, and do it in a seamless way, so they can send requests. So Google has this really cool system of updating their maps, where anyone tells them if there's something out of date on their map, and it automatically sends us a signal up to our satellite, gets down a picture, analyzes the picture, changes it into roads and buildings, and then puts it and updates the map. And so we're allowing other people that aren't as sophisticated as Google to get access to that by being able to put in tips, and then it straight away provides the satellites back. Satellite imagery back. And then finally, the thing to do with SpaceX is that we're launching 2 new sets of these satellites, 6 new satellites, 3 on each of 2 SpaceX rockets, one going this week and one going next month. These are on the piggybacking on the Starlink launches. We managed to find some gap at the top and put 3 new SkySats on each of 2 rockets. First one, as I said, going this week. And that is going to give us this cool new capability where normally we can image every location on the Earth twice per day with the SkySats, any particular location. This is going to enable us to image on average any location 7 times per day. And in some places, like in London, we could image about 12 times per day. And so this is unprecedented frequency of imagery that enables some of what our users are after, which is more rapid understanding of how the planet is changing.
And that's at 50 centimeter resolution, 12 times a day.
That's all at 50 centimeter resolution. Now, that's not the scanning system that scans everywhere. This is a tasked system, but nevertheless, if you ask, we can get up to 12 revisits per day in the daytime of a location on the Earth.
Which are quite a step change from what's possible at the moment.
Yeah, and it was only possible through this partnership with SpaceX. We only came up with the idea less than 6 months ago, and then rapidly readied the satellites, came up with this new interface adapter that sat on top of the Starlink satellites, worked with SpaceX on the launch schedule and all the integration, delivered the satellites, integrated the satellites, and put them on the rocket, and they're going up this week. And so it's really exciting, and only through the agility of the Planet SpaceX partnership, I think, can we pull off something as crazy as that. I mean, for the space world, doing 0 to launch in 6 months is unheard of.
So perhaps, I mean, kind of that leads me to our next question, because I mean, the things that you're talking about now are sort of the perhaps a couple of the big trends in the space sector in the last 2 years. One that's last 10 years or so, perhaps. One that's been the sort of miniaturization and kind of the much smaller and cheaper satellites to launch. And the other one is the sort of the private launch sector, the massive decreases in the cost of launching things into orbit in some cases. How do you see the next 10 years? What are the big things you see?
Yeah, well, I think that what we're going to see in Earth imaging is constant increases in capability. There's 3 main ways you can increase the capability in terms of the raw imagery. you can increase in spatial resolution, that is the pixel size, increase in temporal resolution, that's how frequently you sample a site, and thirdly, you can increase in spectral resolution, that's how many colors that you see the satellite. And I think we will see all three axes exploding. And you will also see novel new companies doing things like synthetic aperture radar satellites, which are really complicated ways of imaging, but then if you can do it, you can see through clouds and at night. So we're going to just see things like that enable imagery to get more and more imagery that enables us to understand the changing planet. And I think that the interesting thing, and I mentioned this the other day to a colleague, that we're having a bit of a Zoom moment here, where because people during coronavirus can't go out and look at that environmental test site, environmentally sensitive site, or their infrastructure in their company, they can't send people out or to check an insurance claim or what have you. They're now using satellite images instead, which is a much more efficient and cheap way of getting the same information. And so we're actually seeing an explosion of interest. And so I think it's a bit of a heyday for Earth observation. It's part of a broader global sensing revolution that's taking place around our planet, with drones and phones and underwater submersible vehicles and all this. But the satellites provide a natural base layer because they scan so much territory. And also with satellites, you don't have to have the same regulatory approvals as ground and terrestrial things, because you're in space, so you're in international territory. You don't have to have permission for each location you operate, like a drone does, for example. So it's a natural sort of base layer that's always global and consistent. So I think that's going to affect. Then the second thing that's going to change a lot in the next 5 or 10 years is your field, Sherif, of artificial intelligence. That's affecting every domain, right? That is the big technology disruptor of our age. But just like it affects others, it affects the space industry. In fact, in many ways, I often think, the first thing an AI, if it ever to wake up, would be is to grab all the satellite data, because the first thing you want to know is what is going on? And we have a huge amount of data to be processed, and it's an AI field day.
Yeah, and well, hopefully AI, we don't get an AI that wakes up and takes over the satellites, but maybe something that because you touch on it there, is the you had it in your presentation. You already have terabytes of data, and you have more satellites coming up all the time. And how do we, maybe one of the issues that we're having as we look into, for example, looking at the Sustainable Development Goals and kind of how to provide the analysis that informs better decision making on them, is how do we actually use all the data we have? You've gone through some of those, looking at road and building detection. What else is possible? What else might you be working on or thinking about?
Well, I think the first step is this better and better precision indexing of what's going on. So, as I said, you monitor the major objects, the buildings, the roads, the ships, the planes and stuff. The next stage is to do that at the next level, right? Well, what kind of building? Is that a school or a hospital? What kind of ship? Is that a cruise ship or a fishing boat, etc.? So you can get sub-classifications. That's the sort of simple thing. Then the querying is the ability to then go, okay, well, just tell me how many ships there are in all the world's ports. Give me a plot of that versus time. Tell me how many houses there are in Cairo. Give me a plot of that versus time. And how many trees are in there in the Amazon? And give me the latitude and longitude. Just tell me the latitude and longitude of the locations of the ones that have been felled between last week and this week. And you should just be able to get those answers back. I think the stage beyond that is more to do with predictability. So if you can monitor all those trends, you can, of course, AI is getting better and better at then extrapolating that into the future. And then saying, okay, well, where is the next urban development likely to be? What will happen to the crops later this year? And things like that.
And perhaps, where do you see in terms of the kind of global setup infrastructure to be able to make best use of that? Let's say, for example, looking at climate change, or I know you've talked about the ecosystem emergency, perhaps as a different framing, and we have the data, we have analytics technology like AI to process a lot of the data, but can you see like that vision of being able to have that overview of the planet and what's happening to it? Is that something that could happen easily, or are there barriers? And if so, what do you think there are?
What can happen easily? Help us to understand this ecosystem?
Getting
the awareness?
Apologies. Yeah, I mean, getting to the point where we can really make best use of all the potential that's there from all the Earth observation data, from the AI analytics that we can run on them, to get the information to the decision makers to make the best informed decisions possible for the climate or the ecosystem emergency.
Yeah, I think so much of that is to do with this machine learning, or more broadly, though, analytics and tools that enable it to be simpler. And so, I mean, you mentioned all the data and deluge that we're getting. I mean, the US government, which is perhaps the most sophisticated user of satellite imagery in the world, is when they heard about our satellite fleet and started using it, they quickly quipped that they would need millions of analysts to look at all the imagery in their normal way. So there's no way they can look at it all, right? And so instead, they have to use machine learning to, instead of trying to look manually through images for ships, they can just be told, here's all the ones with ships, and then you can look at those ones. We need to democratize it so it's not just a sophisticated user like Google or the US government that can really get value out of this imagery. And that means that we've got to have it to a point where you don't have a PhD in geospatial information sciences in order to understand what's in the satellite image. And that's the job, I think, of that is so important that's coming up next. And then just to do with the ecosystem emergency, the thing I was trying to make a point of in that Medium article I wrote on this topic was that I think there's people don't understand what collapse of ecosystems we've got already on our hands here today. People, because of the framing around climate, which I think is a bit of a misframing. Climate is one of the drivers of the massive diversity loss in life around the planet. But over the last 40 years, we've wiped out roughly half of the life on the planet. 82% of all the wild mammals, over 70% of all the fish in rivers and lakes, over half of the coral reefs, the kind that I was showing an image of, all gone, all in the last 40 years. And had that change happened in 4 months, just like the coronavirus hit the planet, we would be massively appalled and changing our behavior to stop that. But because it spread out over 40 years, people didn't really notice at any particular time that this was happening. So we have a massive ecosystem emergency. Climate change is one of the drivers of that, but it's actually the third biggest. The UN report on biodiversity that came out last year showed that the biggest driver of that is deforestation, so land use change, when we change forests into agricultural land mainly. That is, and then overfishing, and we need to stop those things. And then land use change and overfishing are the two biggest drivers of biodiversity loss. And this is exactly where our data can try to help, because you need to have information during those deforestation events, during those illegal fishing events, in order to stop them. Climate change exacerbates the whole thing, but it's actually the third biggest driver. They're completely interconnected, but people think about climate and they go, oh, in 2050 we'll have this, and 2100 we'll have that, and it's so hypothetical. Here and now, we've wiped out more than half of the species on Earth. No predictions, no modeling. That's what we've already done to the planet. And we are wiping out about 10% more of the species every decade. And it doesn't take a genius to realize you can't do that for very long. We are just having a massive destruction on the planet. And I hope that this data can be empowering. If we get those tools to democratize it out, it can be empowering of local decision makers to protect those ecosystems.
Absolutely. And we need to do that fast as well.
Yeah.
We talked quite a bit about the Sustainable Development Goals, the ecosystem, the climate. One thing that I just want to touch on and ask you about is, where do you see, like, looking at the business side of things, where do you see satellite data, satellite imagery applications for business going in the next couple of years?
Yeah, it's a great question. I think it's really exploding. again, the satellite imagery was really the province of governments and big companies before, and now it's being democratized to many other industries. The main industries we've been traditionally working in with agriculture, that's our biggest single sector, which helping crop efficiency improvements, precision agriculture, helping governments, both civilian governments, so we work with NASA on things like understanding climate and climate variables, and local and state government on regulatory enforcement. And we work with countries on security, like coastline monitoring and things like that. And then we work with mapping companies like Google to improve their map layers. And then what's emerging, so those are traditional verticals. What's emerging are things like forest management, insurance, finance, and local and state government, not just the federal governments. So counties and cities using it to monitor environment sites or regulatory enforcement. And the case we signed just the other day was with a county in California that wants to monitor cannabis growing in their area. And it's illegal in California, but they have to still get permits, and a lot of people were still growing it without permits, and so we help them with that enforcement. And that's the sort of thing that is the new use case that, again, like this was always completely out of the province of a local county in California to be able to afford satellite imagery. You know, that was just out of their league, and now suddenly it's into their league and they can do it.
That's it's and I think the more kind of the democratization that I think you talked about, both from the availability of the data, higher resolutions, higher revisit rates, and as well as lower costs, means that a lot of that becomes available to a lot more people, and then getting those used in a way that doesn't require a specialized degree or very specialized knowledge is the second part to that, perhaps. So we have just 2 minutes left, and I just want to ask you one last question. So you were a scientist at NASA. You worked on missions to the moon, and then you became a co-founder and a CEO of a company. How was that shift to you?
Yeah, so it's definitely a very different role. And I definitely very much feel a scientist at heart. That's definitely my passion. But I felt that, and the reason my co-founders and I and our team at NASA left was that we thought we could have a really big impact in a humanitarian sense. So NASA's really focused on science and exploration. And this was very practical, right? In the end, there was lots of technology sort of development, but the application wasn't one of science. It was more one of stopping deforestation or business, driving business with more efficient agriculture. And so in order to do that, we thought we would do that better outside of NASA. And NASA wasn't the right place for that because it was a commercial and humanitarian objectives that we had. And I kind of enjoyed it and enjoy it still. It involves a lot of enthusing about how to take care of the planet, which is something I do a lot of and enjoy. But it's also hard work. And, especially, as the company grew, it's more and more management and things like that, which is not exactly my bent as a scientist, but nevertheless, it's enabling of a lot of people to do a lot of good stuff, and so it keeps me very motivated.
That's great, and thank you so much, Will. That's been fantastic. It's been a pleasure. Thank you.
It's been very fun to chat, Sherif.
Want access to more CogX videos? Subscribe now for free at cogx.co.